Hi, Assalamualaikum and welcome back to my channel Physics from 5 KSSM. So now we continue 4.2 Electromagnetic Induction Part 2. Now we go to the next part, DC generator and alternating current generator. If you look at this one, this is a wind turbine, electric generators. So these electric generators apply electromagnetic induction to produce induced EMF. There are two types of generators, DC generator and alternating generator. Let's look at activity 4.14. Aim to gather information on the structure and working principle of DC generator and alternating current generator. For generator, the working principle is electromagnetic induction. A conductor coil, a copper coil tightly wound onto a metal core, is rotated rapidly between poles of magnet. The magnetic field will interfere with the electrons in the conductor to induce a flow of electric current inside it, thus induce current flowing. Let's look at DC generator. How is DC generator able to produce induced direct current? Look at the basic structure. If you still remember, in 4.1 we have discussed about electric motor or DC motor. The motor applies different concept, which is force on current carrying conductor placed in magnetic field. If you look at the basic structure for DC generator and DC motor, they are the same, but there is a little difference that you can see. In external circuit, for DC motor there must be current supply or voltage supply like battery or power supply. But for direct current generator, there's no power supply because we want to convert mechanical energy to electrical energy. So it's a reverse process. The structure all the same. There are split ring commutator, carbon brushes, coil, magnet. Okay, so let's look at how it works. You can look at here, this is galvanometer, this is coil, this is magnetic field, commutator, split ring commutator, carbon brushes, the blue color. Observe what happens to the reading of galvanometer when the coil is moved in the magnetic field of permanent magnet. Between the north and south pole of the permanent magnet, there are magnetic field lines. Observe what happens to the flow of current. The use of commutator is to ensure that the induced current that produced always flow in the same direction. Okay, the induced current that flow in the same direction, we call it direct current. Same thing as what we discussed before. To determine direction of the induced current, we can apply Fleming's right-hand rule. When rotates in clockwise direction, for side AB using Fleming's right-hand rule, we can get direction of current is A to B. And then for side CD, it moves downwards, so the direction of current is C to D. So now in the coil is A, B, C, D. When rotates in clockwise direction like this, so commutator ensure that the current that produced in the external circuit always flowing in the same direction. So you can see the pointer pointing to right. As you can see, this graph. If the speed increase, the magnitude is bigger, larger current. If the speed is smaller, so you can see smaller magnitude of current. This one move in opposite direction or rotate opposite direction, clockwise direction. So you can see the galvanometer pointer deflect to opposite direction. So as you can see from this activity, the function of commutator is to ensure that current that produced in external circuit is flowing in the same direction or produce direct current. So this is how DC generator produce induced direct current. This is AC generator. The difference between AC and DC generator is, for AC generator, it using slip rings. There are 2 rings that just can rotate here and always touching to the carbon brush. One side of the coil AB connect to one ring, and another side CD connect to the next ring. And then this one connect with carbon brush to the external circuit. Okay, look at what happens and how this AC generator generate alternating current. Let's say rotate the coil in clockwise direction. So you can see how the ring rotates and keep touching to the carbon brushes. As you can see, the galvanometer pointer keep deflect right, left, and so on, showing that direction of induced current always change every half cycle. Okay, observe this one. So when rotates like this, in clockwise direction, the reading of galvanometer always reverse every half cycle. If you are able to plot a graph to show how the magnitude of current flow in the external circuit, you will find this type of graph, showing that direction of induced current always reverse every half rotation or every half cycle. The type of current that always reverses its direction every half cycle is known as alternating current. What are the magnitude that affect induced current that produced by AC generator? We can increase the number of turns of the coil. We can increase the strength of magnet, and also we can increase the speed of rotation. Let's look at the difference between DC generator and AC generator. Similarities, both applies electromagnetic induction. Coil rotated by an external force, meaning we need to apply or we need to supply mechanical energy. Coil cuts magnetic flux, EMF induced in the coil. The differences, ends of the coil are connected to a split ring commutator for DC generator. Ends of the coil connected to 2 slip rings for AC generator. The two sections of commutator exchange contact with carbon brush every half rotation. 180 degrees of rotation, the commutator exchange contact. Slip rings are connected in the same carbon brush for AC generator. The slip rings always in connection with the carbon brush. For the DC generator, output is DC current. For alternating current generator, output is alternating current. For activity 4.15, this is to construct functional prototype current generator or dynamo by modifying an electric motor. In the previous video, 4.1, I have discussed about how you create or build homopolar motor. That one also is one PBL. Now what you can do, you can create a prototype or construct prototype current generator by modifying that electric motor. So this is PBL. Okay, you can just follow the instruction given here. In the end, you need to present the design of your dynamo. Let's look at formative practice 4.2. What is the meaning of electromagnetic induction? The production of an induced EMF in conductor when there is relative motion between conductor and magnetic field, or when the conductor is in a changing magnetic field. There must be relative motion that causes changing in magnetic field. Faraday's law says that magnitude of induced EMF is directly proportional to rate of cutting of magnetic flux. Use Faraday's law to explain effect of speed of rotation on the magnitude of induced current in the current generator. When a coil rotates and cuts magnetic field lines, an EMF is induced in the coil. If the speed of rotation increases, the rate of cutting of magnetic flux increases. According to Faraday's law, the induced EMF increases. We have discussed about Faraday's law, with stating that magnitude of induced EMF is directly proportional to rate of cutting of magnetic flux. Let's look at number 3. Figure shows a simple pendulum with a bar magnet as the bob oscillating near a copper ring. Explain production of current in copper ring when the bar magnet is moving towards the ring. Remember, for the bar magnet, there are flux line direction north to south. When the bar magnet moves towards the copper ring, magnetic field lines are cut by the ring, and induced EMF is produced in the ring. This induced EMF produces induced current in the copper ring. There's an induced current flow in this copper ring. At the position of observer in front of the ring, state whether the current in copper ring is clockwise or anti-clockwise. North pole move towards the copper ring. It will produce north pole here. If you still remember Lenz's law. For north pole, direction of current is anti-clockwise. Explain the effect of the current in copper ring on the motion of a magnet. According to Lenz's law, the anti-clockwise current produces magnetic north pole to oppose the motion of bar magnet. This causes motion of bar magnet to be slowed down because there is a repel force. When the bar magnet moves towards the ring, there is a repel force produced and try to repel the magnet. Thus, the motion of the bar magnet will be slowed down. That's all my video today. You can search more on this topic so that you will understand better. Thank you for watching. Bye.